day 25 in geometry. And again, it is Monday, November 17th. And today we want to start off by just making sure we remember all the things from last week. Let's review a little bit. We had our Unit 3 quiz last week. So sometimes when we do a quiz and then introduce new stuff, that new stuff gets a little jumbled. So let's take a peek back at what we learned about circles. I'm going to go all the way back to day 23 in my notes, and I just want to kind of go through each of the things. So on day 23, we learned about area and circumference. Our area formula is here. We got the pi times radius squared. Now, is radius the smaller length or the bigger length? Smaller. Radius is the halfway point from the center of the circle to that outer edge. Diameter goes all the way across. It's double the radius. So the area is just that space that the circle takes up. Moving on, we then talked about circumference. We have our circumference formulas. We either take pi times the diameter or 2 times pi times the radius. We worked out quite a few problems with circumference. Moving forward, and then on Thursday, we started talking about arcs and central angles in a circle. Now, these were the two really big, important measurements in a circle. We know a full circle is 360 degrees. A half circle is 180 degrees. So, moving forward, let's take a peek at one more thing with circles. We've talked about perimeter, circumference, area. We've talked about angles, but circles can also have lines. We're going to look at line segments. In circles. And we're going to be drawing some pictures so that our circles don't look too wonky. If you want them to look nice and neat, we can use a compass. Our compass is like a circle maker. So while you guys get that titled, let me grab my note guide so that I teach you the right way. Here it is. Okay. So today we are talking about these line segments, and there are going to be two different types of segments that we see in circles. So the first type we're going to talk about are called exterior segments. E, X, T, E. Exterior segment. Now, for this little section of our notes, we want 3 circles. And for those circles, let's see, I need to get a compass that is not as loose. Okay. So I'm going to draw first. I'm going to open my compass so that it is roughly, I'm going to make it a little bit less than an inch open. If you need a compass, if there's not one at your table, there should be over at the farther end. Jess is grabbing one, it looks like. If anybody needs a different compass, there's plenty of at the front. And I'm opening it, again, a little less than an inch. And I'm going to draw 3 circles side by side, leaving a little bit of space in between them. So I will start my first one about here. And I'm going to do a circle best I can. Let me make a center point to start myself in case I have to pick it up. Okay, there's my center point. And I'm going to follow that center point. Stay on it. Turn my paper a little. Compass is a tricky. Okay, there's one circle. And then my next circle, I want to make sure that whenever I have my center point down, I'm not touching the other circle. I'm gonna leave a little bit of space there. I'm gonna put it like there-ish. I'm gonna mark a center point about here. And one more circle. And one last circle, hopefully it doesn't go off the page. Mark about here-ish. So we want 3 circles. I'll outline these to make them darker while you guys get yours drawn on. And I want to wait till everybody's got their circles drawn on their page because the next thing that we will be putting on these circles, we need to be very precise with. So once you have your 3 circles, just give me a little thumbs up so I can keep track of who's ready. And I'll pause this while I wait. Give you guys some time. All right, we're all ready. So for our first circle, I'm going to use a ruler and we are going to draw a line segment that goes through the circle and then goes outside of the circle like this. There's my first line. And then I will draw another line, creating kind of an angle here, like this. So that's what my first circle should look like. And you should end up with 4 different line segments. 1 here, 2 here, 3 there, 4 here. It's really 2 lines, but since they cross through the circle, we've got 4 different sections there, 4 different line segments. And we need to label them very specifically. That first outer point on top, A, following the line going over here on the inside of the circle, above the line we put B. Then below the A, we're going to call this C. And then back inside the circle, below the line, we call this D. So that is our first circle with exterior segments. The second circle, we are going to start with a line that does not go inside the circle. We want this line to be right on the outer edge, and it's going to look something like this. I'm going to draw a little arrow. just one going outside the circle. And then we'll put one line to create an angle, and the second line does go inside the circle. That. Just like this. One line goes inside, one line stays outside. And we're going to label the same way. A on the first top small section. B on the inside above that line segment. Below A, that small segment will be C. And this time, because the outer part of this is not a line segment, this is actually, what would this be called? There was a point here, and then it goes on forever. Array. Array! So this does not get labeled with anything because it's not a line segment. It is infinitely long. We have no idea how long that is. So we don't label it. Just A, B, C. And then our final circle, we're going to draw two lines, both outside the circle, nothing inside. So it will be like this. I'm gonna make these a little more tilted. Do it like that. Arrow. And another one. Make an angle. Do not let your lines go inside the circle. Keep them outside. There we go. And this time we label both of the small sections here with A. Both of them are A. Now, this next part is totally optional, but for me, when I look at this note page, it's easy to start jumbling the letters up. So I am going to color code everything. I'm going to pick out 4 colors of highlighters. Let's do pink, green, purple, so I'm going to highlight everything that is A in pink. So here's A, and then here is the line segment A. Here is A, line segment A. Here's A 2 more times. Both of these are the line segment A. And these green, there's only 2 B's. Showing up a little more yellow for you guys. And I've got 2 C's, I'll move those purple. And then just 1 line segment labeled D. I'll make that blue. Okay, again, totally optional. I just think the colors help. I'll just see what's happening a little better. And once you've got your pictures how you like them, I'm going to give you a few formulas. There'll be 3 different formulas. So for the first circle with all 4, A, B, C, and D, here is the formula we will use. A times, parentheses, A plus B A times A plus B, close the parentheses, equals C times C plus D. Read. And for me, using the colors just helps me to see how many times I'm using each letter, each variable. Helps me visually just to see it. C, C, D. That formula goes with our first picture. Drawing here, I'm gonna give a second formula. Second formula for this second picture will be A times, again, A plus B equals, time will be C squared. Color goes again. C squared. And last but not least, my favorite formula, A equals A. They're the same. So it's really not even a formula. Okay. Pause this and let everybody get that written down. Okay, so moving on. We've done exterior segments, and now there's luckily just one formula and picture for interior segments. So I'm going to scooch my paper down a little. Now I'm going to write interior segment. So if you'll notice, all of the exterior segments have line segments that go outside of the circle. What do we think is going to happen for interior segment? Yes, they're going to be inside the circle this time. So I'm going to draw myself a circle.
Doing one?
Just one this time, just one circle. Yes, you can do this. I believe in you. Outline my circle here.
Getting hard thoughts from the Excel.
I know, right? Like my circle looks so nice until I outline it. Man.
I can do it. It's just
Not when I'm in a rush. I'm trying to not spin forever. Okay, so here's my interior segments. All we're going to do is create an X in the middle of the circle. Nothing goes outside, inside only. So, this one line. Here is the next line. And when we label this one, we need to label this carefully. We drew two separate lines. They are crossing. We're going to start with the first line up here. This is A. Now, when you write B, it's going to be on the same line as A. So keep moving down. B goes here. There's B. Not up here, down here. A and B are on the same line. Okay. So I'll go ahead and highlight those. My B follows the same line. C is going to be right here below A. And on the same line, moving up, D goes here. C. And the formula for interior segments is just A times B equals C times D. So multiplication happening here. A times B equals C times D. So E is really hard to read with that blue over it. But down below, the same thing written out without being I see in case that's hard to read. Same thing. Let's use your formula. Okay. Try to get that all written down. And what's this? All right, guys. So we have our formulas. And I think this would be a great page to put a little sticky note on to keep track of. I'm going to just label this line segments and circles. Segments and then put a circle. I know we're going to use these formulas. Don't want to lose that page. Okay, so flipping to the second page of my notes, I'm going to retitle this. Day 25 continue. Okay. Boop. Got lost my camera. All right. So let's look at an example. I'm going to draw a very rough circle. I'm not using a compass. Just like that. Okay. Now, I am going to draw an X in the middle. Just like that. And inside the circle, we're going to label some of these segments. Let's call this one 4, 6, X, and 9. First thing we want to decide when we have a circle with line segments is, are we looking at interior segments or exterior? These are interior. All of the lines are inside. These are interior. So what formula will we be using? What formula?
A times B equals C times D.
Yes, that means we're going to use A times B equals C times D. So I know what formula I'm going to use. Now we need to decide what's my A, what's my B, what's my C, what's my D. When I am going through and deciding these things, remember that we are always going to stay on the same line before we go to the next set of letters. So it doesn't matter if I start with 4 and 9 or X and 6. I'm going to start, let's see, why don't we make it match our note picture? What would be my A here?
4.
4, that would be A. Let me get, let's see. 4 would be A. What would be my B?
Year 9.
9. We're following that line. So that's B. What's my C?
Near X.
X would be C. Okay. Oh, did I change my colors? I think I did. My bad, guys. I'll call that C. And so that would mean 6 must be D. So now that I know which value is which letter, how could I use that information in my formula to solve for X?
Plug it on.
Plug it all in. If it helps and it makes you a little more organized, you can write those out to the side. A is 4. You don't have to do this step, but if it helps, do it. B is 9. B is X. B is 6. So I'm literally just going to plug those in. A is 4. Times, we said B is 9. Equals, said C is X. Said D is 6. Lots of things to plug in. So I plugged everything in. Once you've got that all plugged in, what would we do from here?
Solve.
Solve. Okay, so solve, what does that mean? What step should I take?
Times. I just.
Times, yeah, my 4 times 9. Okay, let's start with that. 4 times 9 is, somebody tell me.
36.
Good, 36. 4 times 9 is 36. I'll bring down my equal sign. What's X times 6?
6X.
6X. Can I solve for x now?
Yeah, you divide by 6. that's
Yes.
fine.
Divide both sides by 6. So I divide by 6. Divide by 6. Those cancel. My 6's do.
36 divided by 6 is 6.
Good. 36
Equals
divided
6.
by 6 is 6. Equals comes down. X comes down. Ah, that's our answer. Lot of steps, but it's not so bad, is it? No, not so bad.
Really not.
It's really not. Geometry looks really scary, and then you do it, and it's not bad. It's really not too bad. Good. Good, good, good. Okay, so that's an example of one of our interior segments. Wonderful. Let's look at another one. Let's take it a step up. I'm going to draw my circle a little bit bigger this time. Give myself a little more space to write values. And let's stay on the interior ones for now. So we'll use the same formula. Let's not get all mixed up yet. Draw an X again. But this time I'm going to label some other things, okay? I'm going to label all of the points. So this is E right here. This is point F. Moving down, this will be point G. Last one, we'll call this H. Okay. Now, from E to the center, this first line on top, we'll label that with 18. From G to the center on the same line, we're going to call that X plus 5. Now, from 8 to the center, we're going to call that one X plus 3. And from F to the center, 21. Pause it. All right, so what formula will I use for this problem?
18 times x plus 5.
Yes. Before you do that, I'm going to write down that formula. We're using the same one as the previous problem. Okay, and then Riley, you said 18 times x plus 5. Yeah, so 18 would be like our A. So A, we'll do 18 times my B, you said is x plus 5. That's B. Well, and then go ahead. What else?
X plus 5 times 21.
So you're very, very close. We used x plus 5 for B.
Oh, yeah.
Now we need C. What would my C? What value would that
X
be?
plus 3.
X plus 3 is my C. Good. So x plus 3 is C plus 3. That, oh, I don't want to put that in parentheses. I guess I do. Because really, we want to keep all the values. Like x plus 3, all of that is C. That's one thing. And then times D, which you said is 21. So this one looks a little bit more complicated, but we can still do it. I got everything plugged in. Does everybody see where we got this so far? Okay. What would I do now?
You distribute?
Yes, you distribute. Because we're still multiplying 18 times the quantity of x plus 5. When we have two terms in parentheses, we multiply to both of those terms. So yes, we're going to distribute. So 18 times x is 18x. And then bring down my plus 18 times 5. 90. Okay, done with that. Moving on. Bring down my equal sign. Now, what do I do here?
Distribute.
Distribute again. So, how do I do that? What am I going to get? 3 times 21. You got your 3 times 3. 3 times 21 is 63. And then, what about the x? We're going to do them in order, if that's okay. I'm going to do, so it might be a little weird that the 21 is on the other side. You can still do it the same way, just opposite. So 21 times x is, good, 21x. And then we did 21 times 3, which you said is 63. Okay. Now we have an equation that we can solve. So we have like terms all over the place. I'm going to draw that line down the middle, keep it organized. And we have two options. I won't say quite a few. We have two options for what we can do next.
I'll subtract 18 from 21 first.
Yeah, let's get our x's together. Let's subtract 18x. So I'll do that from 21 as well. Do it on both sides. My 18's cancel, we know that. What happens at the next step? 90 equals
3x.
3x plus 63. Okay.
63.
Good. Subtract 63 from both sides. Here.
Bring down your 3x.
Bring down 3x
Be 27.
equals, good, 27.
Yes, divide by 3.
Yep, just divide by 3. Three, and what do we get?
9 equals 8.
Good. 9. Perfect. Perfect, perfect. Now, what if I asked you, now that we have our x value, I want you to go a step further.
Plug it in.
Plug it in. Let's solve for the line segment H, and let's solve for the line segment G to the center. So how would I do that?
Just take 9 plus 3 and then 9 plus 5.
Yes, so
So
we
9
can,
plus 3 is 12.
good. So we could plug in that 9 plus 3 instead of x, and we get 12. And then for G,
9 plus 5 is 14.
good, 9 plus 5. 14. Very, very nice. Okay. Now, I know that that probably looked a little bit more difficult, but how did that one feel?
Okay.
Not bad? Okay, good deal. Good deal. Good. Okay, so before we do any more practice with these, I am gonna, it's, let's see, 1:52. I'm gonna let you guys have your break a little earlier than normal because I want to print off some practice worksheets for you guys. That way you're not having to draw circles a million times.
Another driveway, get the exit to it.
I do not have that ready yet, but I will give it to you soon, tomorrow. Or do you want me to like send you an email picture of it whenever I do have it ready?
You can,
Okay.
won't be able to do it until tomorrow.
Well, I'm sorry.
Then I just stick it in my folder and I'll get it in the morning.
Okay. All right, so I'm gonna go ahead and pause it there. Take a break. Take a back from our break, and each of you should have this worksheet. So, the problems that we worked out as examples, we started, the very first one we did together is like all the ones on the first page. And then, if you turn the page to the second side, 9 and 10 are just like this one as well. Now, the second example we did together, I actually took from number 16 here. But I want us to focus on the second page at some of the problems that we have here. Because now you're being asked for a few different things, and I want to make sure we understand how to do this. So let's look at number 11. First of all, there's some directions that we have here. It says find the measure of the line segment indicated. That means we have to find x and then plug it in. Assume that lines which appear tangent are tangent. Tangent. Has anybody heard that word before?
Yes.
Yes? Does anybody know what that means? Tangent? Have you ever heard of somebody saying, sorry, I went off on a tangent there? So basically, a tangent is going off course in some way. So, for example, if I'm looking back at, let me pull up that note page that we took today. If I am going in a circle, round and round and round and round, I'm on the course, going off of the course, right outside of the circle, like this line here. This is a tangent line, meaning it does not go inside the circle. It follows the outside. This is a tangent. These lines that come off of A would be tangents here. So, just so you know, that's what tangent means. These are tangents. Tangent. That's all that means. It's these lines that don't go inside the circle. They cross right out on the edge, the outer edge. That's all that means. It's just like on when we were looking at arcs and central angles, and the direction said, assume if it looks like a diameter, it is a diameter. It's just to help you know, you don't have to second guess yourself. If it looks like it is on the outside, it's on the outside. So, looking at number 11. Let's see what we have going on here. First of all, it says we need to find DE. So, which segment, the DE, what is that labeled with? Have we seen that anywhere? See D here, E here. Yes, x minus 1. That is DE. So the first thing I would recommend doing is find the thing they want you to find and label. DE is going to be x minus 1 eventually. That's what we're going to plug into at the last step. What DE is. Okay. So I know that DE is x minus 1. Now, let's look and see what type of segments we're actually looking at here. So go to your note page and let's see how many segments we can count. First of all, are these interior or exterior?
Exterior.
Exterior. There are lines outside the circle, so I know I'm looking at my exterior formulas. All right, EXT for exterior. And let's see. The first formula for exterior has 2 lines inside, 2 lines outside. The second one has 1 inside, 2 outside. The third one has 0 inside, 2 outside. So really we want to see how many segments are inside the circle for number 11. 2, 1, or 0. So let's see. I know I have at least one that VE is inside. Yeah, there's another line segment here from J to G, and that's labeled with 5. Okay, so if I know I have 2 line segments inside, which formula will we use? The first one. That's the A times A plus B equals C times C plus D. So we need to figure out what is my A, B, C, and D. So over to the side, I'm going to label A, B, C, D. And you may have to turn your paper to the side to make it match your picture and your notes. Let's see. I'm going to turn it like this. What would my A value be?
3.
3. There's 3, so we'll call that one A. Three is A. Now I'm on that same line. What's my B? 5. Good. I'm going to turn it back to normal now. It's confusing me a little. So B is going to be 5. What's C? 4. And what's D? Yes, X minus 1. That's D. Okay, so I have all of my values. Now we can plug them in. So let's start with A. Let's plug in A anywhere that we see it in our formula. I have an A right here and an A right here. So I'm going to put 3, parenthesis 3. What comes next?
5.
Yes, we've got plus B plus 5. 5 is our B. What do I write next?
Equals 4. C.
I'm going to close my parentheses first. Equals 4. That's C. Then what?
Parentheses 4. Plus X minus 1.
Yes. Plus B is X minus 1. Okay. Everything is plugged in. So once I've got all of this plugged in, what should we do?
Distribute.
Distribute. Okay, so what do I distribute first?
3 degree.
3 times 3 is 9. And then what?
15.
Yes, 3 times 5 gives us 15. So I've got that side done. Equals. Now, on this side of my equation, I'm still distributing, but now I have 3 terms inside parentheses. What's the only thing I need to do different here? You could do the parentheses first. You absolutely could. You could combine your like terms if you want. 4 and a minus 1. If you don't want to have to switch your method, you can still distribute. You're just going to distribute to 3 things instead of 2. You're going to do the same thing, starting with 4 times 4. What is that? 16. And then I've got 4 times x. 4x. And then one more. 4 times minus 1. -4. Beautiful. That's all you do different. You just multiply one more term. And now, let's do what you said, Seth. Combine like terms. Okay, so what like terms do I have to combine?
Negative 4, negative 1.
-4 and
Oh, this one?
yes,
Oh,
we're on this
okay,
step.
okay.
What do we combine?
16, negative 4.
Good. 16 and -4. We can combine those. What do we get?
12.
Yes, 12. So I'm going to actually bring down this 4x so I don't lose it. And then I'm combining the 16 and the -4 to give me 12. And what other like terms do I have? 9 and 15. What does that give me? 24. Okay. Now what?
Well,
Yes, let's subtract 12 from both sides. Get these all together.
4x equals 12.
Good. 24 minus 12 is 12. Bring down my equal. Bring down 4x.
X equals 3.
X equals 3. We divide by 4. X is 3. 3 is x, depending on how you wrote it.
We plug that 3 back into the X.
Yes. Yes. So this is not our final step. We have our x value, but now we want to find DE. Good thing we labeled it earlier, because once you've got all this, it's a little bit harder to find where you started. So we saw D to E is x minus 1. So plug that in. And what is DE? 2. Is our answer. DE is 2. Very, very nice. Okay. It's a long process, but we got it. We can do it. Okay. Do you guys want to try some of these on your own, or would we feel better if we ran through some more together first?
Do one more together.
One more together. Okay, let's do one more together. How about we do one with a formula we haven't messed with yet? Let's look at number 14 next. Number 14 we'll do together next. And before I move this completely, does anybody need to see this still? Anyone still writing? Let's scooch this up. Let's do number 14, and you guys try some on your own.
You said,
Mhm.
DE equals 2?
Yes.
Where?
So we said earlier that DE is x minus 1.
Oh.
X is 3.
Okay.
Yeah, you got it. No problem. Okay, so now let's look at number 14 for real. 14, we want to find LK. What should I do absolutely first thing? Let's start labeling. Okay, so what should I label here?
M to L is gonna be your A, 32.
Ooh, yeah, okay, so M to L would be A.
L to K is gonna be your B.
L to K. 2x is going to be our B.
M to N is gonna be your C.
Good. M to N, 40 will be C. Is there a D? No, there's no D. Just A, B, and C. And what are we trying to find?
Okay.
LK. What's LK labeled with?
Okay.
2x. So, not a bad idea. But also label the value you want to find, LK, with 2x. This is what we plug into at the very end. So I have absolutely everything labeled that can be labeled. What should I do now?
Start plugging it into the formula.
Okay, plug it into the formula. What formula should we use?
Our second exterior segment.
Yeah. So, scooching over, looking at my notes. My second formula, A, B, C, looks like this. A times A plus B equals C squared. So I'm going to copy that down. A plus B equals C squared. Now we can start plugging in. So what will I write when I plug my values in?
8 is 32.
Good, 32 for A. Put that in for the other A as well. Then what?
Two X.
B is 2x, good. Plug my parentheses equals. And what goes at the end?
See, so
C,
this one is 40.
40 squared. Good. Perfect. Everything is plugged in. Okay, so what do I do now? Distribute. Okay, so 32 times 32.
1,000.
Good. 1,024. 1024. Bring down my plus. And now I have 32 times 2x is
64 X.
good, 64x. Bring down that equal. Now what?
40 squared.
40 squared. Am I going to type 40 times 2 in my calculator?
No.
No.
Yeah.
Do not. It is 40 squared or 40 times 40. So, always a good thing to be reminded of when we do square. I'm going to type 40, 40. There's the X squared button. Use that. Enter 1600. 1600. Okay, so let's see. So I now have 1024 plus 64x equals 1600. Now what?
Subtract.
Subtract. What should we subtract?
The 1,000.
Perfect.
4.
Okay, let me-
Subtract 1,600.
Yes. Subtract 1024 from both sides from the 1600. Cancel them on that side. What comes down?
64.
Good. 64x.
576. Yeah, 576.
You said 576?
Yep.
Perfect. So 64x equals 576. Divide by 64.
X equals
X equals 9.
Yep.
Perfect. X equals 9. Okay, are we done?
Absolutely.
Absolutely not. Gosh, what do we do? Last step. Plug it in. Okay, so X is 9. We want LK. LK is 2X. What's LK when I plug that in? 2 times 9. And LK equals 18. LK equals 18. Good. Long process, but we know how to do every step. We do.
Yeah.
These are
confident.
good. Good. These are all things that we've been building up to. And that's why geometry sounds and this looks really scary to somebody who's never done geometry. And you guys are doing it with ease. I love it. Okay, guys, I am going to leave this up for a second. And what I would like for y'all to do now is try as many of these on your own as you can. Yeah. Do some practice. Try some on your own. If you get stuck, let me know. I'm happy to help. And whenever I'm going to set a timer. Whenever that timer goes off, we'll make sure that we're all feeling good and confident about these. We can address any mistakes that we're making or not. Or maybe we're all doing excellent. So I will pause our video, set a timer, put on a little bit of music. And then we'll talk about that here in a minute. So pause. So you guys have had a good 20 minutes or so to try some of these on your own. So tell me, which numbers did you try? I know, Jacqueline, you did 13 and 15. What answer did you get for number 13, Jacqueline? Do you remember?
18.
18, was that the one with the 7 plus x and the 7?
7 plus 4 plus 7.
Okay, so your x was 4,
I got 18 as well.
and then 7 plus x. So we needed to find JL. This one was tricky because JL from J to L actually includes two segments. It includes the 7 plus X and the 7. So we need to plug in our 4 here, and we're adding these together. This actually takes us all the way back to Unit 1 when we learned the segment addition postulate. We're adding these two segments together. So 7 plus X plus 7 is JL, 7 plus. And our X is 4 plus 7. And 7 plus 7 is 14, 15, 16, 17. JL is 18. Very nice. Okay. How about number 15? What did you get for that one again?
21.
21. What was your X value?
3.
3. Okay, so our X value was 3. We wanted QS. Here's Q, here's S. That means we want the whole thing. The 5X was 3 plus this 6 here as well. 5 times 3 is 15. Half 6, we do get 21 in QS. And then you got X is 3. Does anybody want to see either of those actually worked out, how we got our X? You want to get a different answer they're not sure about? Are there any other problems that anybody did that you might just want to check to see if you got the right answer, other than 13 and 15?
I did 14.
14, okay. Oh, that's the one that we just did.
Oh, I'm sorry. I thought you were saying. Okay, I'm sorry. Yeah,
Okay.
yeah, I got it.
Okay,
You got
good.
12?
Was it 12 that you wanted?
No, because I think we did that together.
Did we?
I think
No.
we did that together.
I thought we did 14 and we didn't do
14.
12. I just
We're
did
gonna do
this
12.
one.
We're gonna do
Okay.
12.
I'm sorry. Okay.
That's okay. Okay, so here's
Okay.
12. So I just did number 12 on my own. And if you did this one, these are the answers I got. Tell me if they match. I saw my A from S to T was 4. My B from T to U was X minus 3. And C was 6 from S to R. So I plugged that in to the formula that is A times A plus B equals C squared. That's the one that only uses A, B, and C. A is 4, plugged that in, plus B is X minus 3. Okay? Went through and solved it, and I got X equals 8. Did anybody else do this one? You did it? Did you get the same answer?
Yeah.
Sweet. Okay. And when I plugged that in to find SU, from S to U, it's another one of those double lines where I needed to add the 4 and the X minus 3. And I got 9. You get the same thing. Sweet. Okay. Well, good. Did anybody do number 16? I know these take a while, so it's okay if nobody got there. Anybody get to number 16?
Almost, I got the 15.
Almost. You got 15? Okay. I call that a win, you guys. Do you have any other questions
I
about
jumped
these?
around a little bit.
Okay,
because
so
I
tell me
wanted
some
to-
more. What else did you do?
I did 17 and then I started on 19.
Okay, so let's look at 17. So 17, what did you get for X?
8.
X is 8. Okay, and how did you do that?
I used the second exterior segment formula,
Okay, so that means the,
C squared.
yeah, A times A plus B is C squared. And then, what'd you use for A?
My A was K to L.
A to L. Okay, so that's A, or 8.
B is L to M.
Good. B is L to M. So that means C, go ahead.
A to J.
J, perfect. Well. Okay. I assume you just follow the same process we've been doing. 8 and 8, went to the store, got a Nintendo 64, okay, and then 8 comes back. 8X, 82. Let's see, okay. 12 and 12.
144.
144. I'm kind of speaking through now. Okay. Combine your like terms.
80 plus 8x.
8x 80. Bring down everything else.
80 from both sides.
Good. Subtract 80.
64. Divide by 8.
Beautiful.
On both sides.
And we get
X equals.
perfect.
Then you plug that into the x plus 2.
Perfect. LM is x plus 2. So,
LM equals.
perfect. LM x plus 2. Just found x is 8. So, 8 plus 2 is 10. Wonderful. All right. Okay, how do we feel about these? Did we do okay? On the worksheet, we feel good? Good. Okay. Well, I have an exit ticket for you. And when you finish, you are free to go. The exit ticket is actually number 21 off this worksheet, but I already made copies, so I will pass these out to you. It's just going to look like this. Nice big print. It's number 21. I will leave this up on the board though in our recording, and I will pass these out. And then y'all have a lovely day.